So sometimes when you're going to use trigonometric substitution, it's not obvious that you can, and sometimes you have to complete the square in order to put things into a form that's conducive to trigonometric substitution. So if you look at the first example, it have the square root of x squared minus 4x. And what we want to remember from pre-calc is we can complete the square on this. I have x squared minus 4x. And in completing the square, we take first we need to know that the leading coefficient is a 1, which in this case it is. And to complete the square, you take the coefficient, in this case minus 4, that's on the linear term, or the term that's to the first power. You just take the linear coefficient, divide it by 2, and you square it. And then you add the quantity that you get here. But you can't just arbitrarily add a quantity, so you turn around and subtract that same quantity. So 4 minus 4 is 0, so we still have the x squared and minus 4x we started with. And then we've just completed the square on these terms, so we can rewrite it as x minus 2 quantity squared, where this piece here and the operator are always going to come from the thing that you squared, and it'll be minus 4. So this integral then could be rewritten as the integral of the square root of x minus 2 quantity squared minus 4, 4 is just 2 squared, dx. And now I do have a form that will allow me to set up a right triangle. This is a difference of two squares. So the side that isn't, the length that isn't being subtracted has to be the hypotenuse. So we get x minus 2 on the hypotenuse. 2 is going to be the length of one of the two sides. It's your choice where to label it. And the square root of that whole mess, the square root of the x minus 2 squared minus 4, the square root of that mess is going to be the length of the other side. And here I've got all three terms of a quadratic. I can complete the square on that the same way, x squared minus 4x minus the 3. I would still take, as long as the leading coefficient is a 1, I would still take the linear coefficient, have it, square it, whatever I wind up with here, I add it. I turn around and subtract it right away so that I've effectively added 0. And then I have completed the square. So I get the x minus 2. Whatever gets squared is what goes in with the x. When you square this out, the binomial out, you should get back the previous pieces. Minus 3 minus 4 is minus 7. And then I can rewrite this as the square root of x minus 2 squared minus, and 7 is really the square root of 7 quantity squared, dx, and that would let me set up a right triangle again. So if I have this as my angle theta, I have a difference of two squareds, so the thing that isn't being subtracted is the hypotenuse. One of the side lengths is square root of 7. I can put square root of 7 here or here. It doesn't matter. And the other leg will be the square root of the sum of the squares. So the square root of the x minus 2 quantity squared minus the 7 would be the length of the other leg. So either way, completing the square can be a tool that you need to use to get your integral into a form that allows you to attack it using a trigonometric substitution.